Good morning, everyone. How are we? Good? All right, so thank you for that presentation previously. I'll be coming to you from the climate and ocean perspective. And I've noticed that most of the presentations I've done previously is just to do with food, more on land. But from a presentation, I'll be coming to you from the ocean perspective. So I'll be looking at how climate influences the ocean and how the ocean responds to that through its productivity and how that affects fisheries and stuff. That's what I'll be presenting to you. So the topic that I'm working on, so this is my master thesis, is entitled The Influence of ENSO on the Rise of Equatorial Waters, or in other words, upwelling in the Pacific, and what that would mean for fisheries for us here in the Pacific. So my study is based mainly on the Pacific Ocean, so I'll be taking you through what the Pacific Ocean responds to climate as it changes, different dynamics and stuff. So my name is Shaderch. I'm a physical oceanographer, which means I'm specializing in studying the ocean and stuff, and climate as well. I'm currently working as a lecturer for the Sunrise National University. Right, so the outline of my presentation is there right in front of you, so you can see. I'll be briefing you about a little introduction of what ENSO is, just in case some of you don't know what ENSO is. And then giving you a little background of what ENSO is. And then we'll go on to look at the objectives of what I wanted to achieve, which is why I'm doing the study. And then we'll look at the data I'm using and the methodology I'm using to do the analysis I'm working on. Then we'll look at the findings, so what did I discover from a study. And then we'll go on to look at the discussion of what the analysis did. And then we'll conclude that with the implication. And then we can ask questions to me if you have one. All right, so as I've said already, just precaution, I'll be coming from a climate perspective, which means I'll be talking more technically from the physical oceanographic perspective and the climate. So pardon me if I'm using a lot more technical words. You can ask me after if you're not sure what these terms are. All right, so ENSO, it's a big term, was it? Quite big. But it was put in short as ENSO, and probably most or majority of you will probably understand what ENSO is. It's shortened for El Nino Southern Oscillation, which is defined by NOAA. Other organizations have their own description, but I'm using NOAA's description and definition that I've put in front. So it's defined as recurring climate patterns involving changes in the temperature of the waters in the central and tropical ocean, which means it's all to do with how the ocean responds to the different climate. So when it's warm, the sea surface temperature will either move to the central or eastern Pacific. When it's cold, it responds by reversing, which means it moves backwards and stuff. So that's the definition. And it ranges from a period from 3 years to about 7 years. And ENSO itself has affected quite a lot. If you're talking about crops and stuff, you probably might have heard about ENSO and how that impacted cocoa, banana farming and stuff. But with the ocean, it has a large implication as well. So on the right there, you can see the different, so the color stays denoted by sea surface temperature, which means the warmth of the surface of the ocean. So the yellow at the top, the figure at the top there, tells you the sea surface temperature of the ocean in the Pacific. So that is El Nino, which means it's warmer in the central and eastern Pacific, but on the western Pacific it's a lot less warm, so it's not really warm. And right down below that is La Nina, which is where the water at the central, Equatorial Pacific, central and east, it's a lot more colder, denoted by the blue color. In the western Pacific, it's a lot more warm. So that's the definition of what El Nino is. All right, so El Nino has 3 phases, which means it has what they call La Nina, and then moves back to neutral condition, and the other phase is El Nino phase. So La Nina phase is during the time when the wind strengthens, which means the trade winds that normally blows from east to west of the Pacific blow stronger. So what that means is that it pushes the water on the surface, the top surface of the ocean, to the left side of the Pacific. And what that does is it brings along with it the warm sea surface temperature. So what that does with it, just because it moves the sea surface temperature to the Western Pacific, it allows for the cold waters from the deep ocean to change that, means they upwell or comes to the surface to replace the water that is being replaced to the Western Pacific. And this is why you've got sea surface temperature normally is a lot more cooler in the central and the Eastern Pacific. And it's depicted by the figure that to your right. And that is the same as neutral as well. So neutral is a lot more, not exacerbation, but you have the same phase. But with La Nina, it's a lot more exacerbated, which means it's strengthened. So which means the wind gets stronger and it pushes the water to the left a lot more than during the neutral phase. And then what you get from La Nina period is this one here. So the areas there is what Ekman transport does. It's one of the dynamics of the ocean. So when the wind blows, it diverges either north or south of the equator because of what they call the rotation of the Earth. And that allows for the water to either move north or south. And that allows for the colder waters from the deep to get upwelled or move to the surface. And that will allow for more nutrient water from the deep to reach the surface. And that will then lead to more productivity of the ocean on the central and eastern Pacific. And this is what you get. So this is the satellite data from NOAA that gives you, the green color gives you the chlorophyll concentration, just denotes productivity of the ocean. So a lot more productive central and eastern Pacific during La Nina period. Alright, so what happens in the opposite? So the opposite phase is what is called El Nino period. And for that, what happens is that the wind weakens, which means the water is a lot less, not pushed to the Western Pacific, but it just sits on the central and eastern Pacific because there's no wind blowing to the west of the Pacific. Or either the wind just breaks down, which means it doesn't move the water to the west. And that will mean that more of the warm waters will just sit in the central and eastern Pacific. And what that do is, it does not allow for the water to come up to the surface, colder water, that normally happens during a La Nina period. And that will mean the subthermal upwelling. So that means normal productivity for the ocean in the central and eastern Pacific. And that is where my question arises. So our normal understanding as a climate scientist, this is just another example of what the data from NOAA does, NASA, sorry, that it depicts in 2015, during the strongest El Nino period, you've got warmer waters in the central and eastern Pacific, which is what you see on the figure there, which does mean that no colder waters from the deep gets upwelled to the surface, which will mean no productivity on the equator. So that's what happens. But we know that productivity is very important for fishes, right? More productivity, more fish for us. But for El Nino period, that doesn't happen because it shuts down. It doesn't allow colder waters to get upwelled. And that is where my question arises. So our normal understanding, or they call it conventional understanding as a physical oceanographer or climate scientist, we say that during El Nino, there's no upwelling, no productivity. But the question I'm asking is, does that really happen? Does El Nino really start turn upwelling in the equatorial Pacific, which is what we see on the previous figures that's shown here? So that's the question I'm asking, and that is what this study is all about. So the key focus areas here is to look at Ekman transport, the wind stress, and identify different regions in the Pacific where upwelling happens. And then compare that to the conventional understanding of shutting down of upwelling during El Nino period. And then looked at any link to that, to the productivity, so any link of the shutting down or upwelling of the waters during El Nino period to the productivity of the ocean and how that will support fisheries in the Pacific. So that's the primary focus of my research. Right, so the data source that I use is from EDA5 Copernicus free analysis data set. It's a lot more technical term, but what that means is this data is from European data set. It's the 5th generation of the sea surface temperature data. Not only sea surface temperature, but I'm using sea surface temperature, which is why I'm saying sea surface temperature, but it's the 5th generation of the data that European Union they've put on their website from the modeling that they did. And it's a reanalysis data set. So what that did is they get that observational data and they rerun it again, which means they already get the data they've gotten from the observation, but they rerun it again using modeling, so that they covers a lot more area, because during observational period, you only cover certain areas. But when you do a analysis of that, you're a lot more comprehensive, because you cover the different areas, different waters of the ocean, which will give you a lot more comprehensive understanding of how it changes the dynamic of the ocean. So that's the data I'm using, and now I'm using sea surface temperature data and the wind stress data, which is what I'm using to do my analysis. And then what I did, I divide the Pacific region, which is what you see on the east, the right-hand side of the figure, into region A, B, and C, so that it's easy for me to compute the dynamics of the ocean and do my analysis on it. And that, I use that to do my analysis and see how it develops over different El Nino periods. All right, so the quick finding from what we did. So on the figures above there, you can see is the different El Nino years. So there are different El Ninos that we've encountered in the Pacific, and the one that you see there is 1997. That's one of the major El Nino that happens to be affecting us Pacific. And then 2015-16. These are two of the strongest El Ninos. So I'm using that to do the analysis. And then what you get is that during El Nino period, you've got shutting down of upwelling, but then the other thing is that at the higher latitudes a bit, you've got persistence of upwelling, which means there is downwelling in the equator, but the regions up above the high latitudes of the Pacific, you've got upwelling on that. So there is sort of like a balance in the act. So even though you've got shutting down of upwelling, you've got upwelling in the wider regions, the higher latitudes of the Pacific, which is quite interesting from the findings that we did. And then just a case study in 2015, which as you can see, it's a lot more upwelling in the 10 degrees north, 10 degrees south, while in between the 10 degrees, you've got downwelling, but a lot more upwelling in the 10 degrees north and south of the Pacific, which means that we'll still have productivity in this region that counters what is happening across the equatorial Pacific. So what we discover is that we know that Hawaii, Samoa, and Tahiti shows consistent upwelling. These are regions that sit at a high latitude a bit from the equator, which means they still have productivity because they have upwelling there. And then wind interaction with localized island, which is what happens in these different islands, still occurs during El Nino period, which is sort of like counterintuitive to what our conventional understanding of shutting down of upwelling during El Nino period. And then also, we've got Peru and California coast, we've got upwelling as well, which means more productivity there, rather than it's a lot less productivity, which means it also counters what our conventional understanding of low productivity during El Nino period. And then we say that because of this different upwelling in the higher latitude regions, it sort of like offset the equatorial downwelling that we experience in the Pacific. So that's what we discovered, and we conclude that because of the upwelling in the higher latitude regions, we say that even though there's El Nino happening in the Pacific, we will still have fisheries because we will still have productivity in the Pacific. That will provide us with more productivity, more fish for us here in the Pacific. And then for future directions or future studies, we wanted to look at La Nina and neutral phase of ENSO, which will enhance our study of what we did when we look at El Nino periods. And then also try and collect in situ data. So we look at the data from organizations like SPC, IRD, or fisheries organizations in fisheries ministry in the Pacific, and try and correlate that to what we discover from our study. So that is my study, and thank you very much for listening. Apologies for the technical terms I'm using a lot.
Thank you so much. Thank you so much for the presentation. I will give you the floor, so any questions or comments? question?
Thank you very much, Gani, for your nice presentation. Just for the sake of others, my name is Lindo. I'm also an academic staff from Solomon Island National University. My question is on when I look at the information that you gave, you mentioned about the chlorophyll concentration mentioned in the ocean. You talked about La Nina and El Nino as well. Is there any reason why we have chlorophyll concentration exists in the tropical area or in the equatorial area? Can you elaborate what is the reason behind this one?
Alright, so good question, Dr. Lidlam. Yes, so from my understanding as a physical oceanographer, normally in the ocean, you've got high chlorophyll concentration down in the deep ocean than at the surface. So what happens during La Nina period is because the warm waters gets pushed to the Western Pacific, that means that the colder waters from deep have to sift in. They get pushed up to the surface to replace the waters that are being replaced. And what that does is it brings in more high chlorophyll and high concentration of chlorophyll productivity for the ocean to the surface, which is why you get more chlorophyll at the surface. Because of the high chlorophyll from the deeper part of the ocean get pushed up to the surface. But you don't get this during El Nino period because the colder water doesn't get to the surface because of the shutting down of that upwell waters. But during La Nina period, this is what happens. So normally when you look at satellite chlorophyll data, you can get this one. It's a lot more greener, a lot more high productivity during La Nina, but that's not happening during El Nino period. So this is why you get more chlorophyll data on the chlorophyll on the surface because of the upwell waters from the deeper part of the ocean. And this is why you get this one. That doesn't happen during La Nina period. So that is my understanding from how it circulates waters, and it does happens during the different climate system and climate conditions. Thank you.
So my name is also from Solomon Island National University. Just in relation to the high concentration of chlorophyll as well. Is it due to high concentration of phytoplankton from the deep, or what do you think about?
Good question.
Is there a relationship between the high concentration of chlorophyll and the phytoplanktons from the deep?
Yes. So thank you for the question, Dr. Hugo. So yeah, there's correlation between chlorophyll and phytoplankton. Chlorophyll is the food that phytoplankton eats. So when you see a lot more chlorophyll on the surface, you're expecting more phytoplankton and zooplankton on the surface, which will then lead to more fishes to come in to eat the phytoplankton. So because of high chlorophyll, we're expecting more phytoplankton to be on the surface to eat, to get the energy from that. And then zooplankton comes in and eats the phytoplankton, and then the little fish comes in and eats the zooplankton, and then tuna comes in to eat the zooplankton or other fishes that you can probably name. So that's the food chain and the food web that happens on the surface and on the ocean. So that is how chlorophyll is related to phytoplankton and zooplankton. So chlorophyll is the food that phytoplankton and zooplankton eats. Thank you.
Yes, I have a comment, but I need to link with Jean, because when I was young in IOD, my colleagues said in Polynesia there is no tuna at all, except in Marquises. Because there is, they assume that the temperature was not good. In Marquises you have tunas because the temperature was good. It was enough hot to have skipjack, because skipjack has not enough blood irrigations to good depth. But when people begin to catch fish at 200 meters depth, they find tuna. So it means that in French Polynesia you have tuna. It means that probably the water are too cold to have skipjack all the year round. So when you say that you have upwelling in French Polynesia, in a El Nino period, okay, the waters of French Polynesia are warm enough to have tuna, but in normal time, there is no upwelling. So, because I noticed that you say that in Polynesia you have upwelling all the time. So I don't catch what you say.
At this point,
I think that like that. something. I don't remember maybe.
This year, right?
Yes, show consistent upwelling.
Yeah.
But when does it? It was.
So
at what time is this consistent?
this is during El Nino periods, so not all the time.
Okay,
Yeah,
okay.
just during El Nino. So which means
El Nino it's normal.
Yeah.
El Nino it's normal.
during El Nino you've got upwelling, but during La Nina that's the opposite. So that means it doesn't happen. So every El Nino you've got to have because it's consistently happening. So you should expect your tuna there.
One other comment. I remember in 2002 the meetings in XPC of headquarters of each fishing department in the region. The question where are tunas? In this year, nobody find any tuna at all in the Pacific Oceans. No skipjack in Solomons, no skipjack in Fiji. So people say that they should be in the east. And we asked two people of east, a French manager said no. So unfortunately, nobody came from Rapa Nui. Maybe they could always in all in Rapa Nui, but it was very strange. Nobody knows what's happened to the tuna in 2002. So it could be interesting to assess what happened in 2002 in terms of El Nino, La Nina, and so on and so on and so on.
Good comment. I probably might explore that. It's interesting. There's no way we can think that El Nino would exist. Well, tuna would exist because of that, but then because of what you say, probably because we can overcatch them. That's the other thing. So the tuna declines. But I don't know. We have to look at the data and verify that this happens. So it's one of the things I probably might be interested to look into. So good comment for you. Thank you.
Thank you so much.